All right, so now let's see what's going on. We've got or, we've got an and. So we're making progress, but still kind of gross. Okay. What I'm going to do here, I notice a couple things. I notice that I have a couple combinations that I could potentially make to get a true or a false, which would allow us to condense this whole big gross thing down. Okay. What I notice if I've got a not P, I've got a not P, and I've got a P. If I could combine those, that would be awesome, because I know, let's see what I know, what we know. I know that if I combine P and not P, or P or not P, I'm going to get true or false, right? So that'll allow me to condense things down. And the same story goes with R. I've got an R and a not R. So it'd be really nice if I could take that green and kind of put them where they're most useful. And what's nice is we can actually do that because we've got things only connected by ors here. These guys are grouped, you know, ands, and we do those first, okay? So I don't have to worry about that right away. All I need to focus on is our outermost operation, and the operation we're dealing with right now because of the parentheses is the or. So what I'm going to do here first, because I kind of want these not P and those that are, I want them to be free so they can move around. Okay, so what I'm going to use is the associative laws for or, the associative law for or. And the associative law says, it's just based off of the commutative law, right? It doesn't matter the order that we do the operation as long as we've got the same operation. That's tricky, right? It all has to be or and. And so you say, oh, there's multiple ones going on, but I'm just focusing in on these bigger ones because those ands are grouped, okay, separately. So what I'm going to do is use the associative law. P or Q or R is logically equivalent to P or Q or R. Okay. So what that allows me to do is to group, and this is going to get kind of lengthy. I think there's a step that I would generally do here, but I'm not going to do it because I want to do it the long way so that you're really super convinced, okay? So what I'm going to do, so instead of grouping these two first, I'm going to group, well, I'm going to group these guys, okay? And then use commutativity to move that not P by the P that I want it to be, okay? All right, so what I'm going to do, I'm going to group each of those three at the beginning. So I've got P and not Q, I've got or, I've got Q and not R, I've got or, not P, okay? And then I've got or R still. Now, commutative property for or says that I can do it in any order there. So P or Q is logically equivalent to Q or P. And again, you're not going to know all these off the top of your head, okay? You're going to have to be referencing that table. Those tables are going to be your friend, okay? That PDF with all of them. So you're going to be looking at these and thinking about which ones you can do. I've done this, so I know all of them. I've got them in my head for the most part. So keep that in mind, okay? So I want to move this not P by this P, so that somehow, hopefully, I can do it. And I can do it because I've got this or operator going on here. So what I'm going to do is I'm going to move that not P by the P and not Q. Or not P or Q and not R. Or R. Yeah, I'm liking that a little bit better. I'm going to do one more thing here before I go crazy with distributive stuff. I am going to I'm going to go ahead and use that same idea here, the associative idea, to group these two guys because I want the R with the not R. Okay, so let me just write down again so that I can remind you of that associative law. If I've got, let's see, in this case I've got P or Q or R, I know that that's logically equivalent to P or Q or R. Okay, and it might be hard to see because it's a lot more complicated than the logical equivalence the way that it's presented, but hopefully you can see that that's actually what we're doing here. Instead of grouping these three things, I'm going to group these two things. Okay, and I can do that because I've got the same operator there. Okay, so let's do, oops, that guy went a little bit smaller. So let's go ahead. I want that P to stay by its not P, so I'm going to just leave that grouped. And I'm going to kind of think about these guys as two little separate problems, because otherwise it looks pretty overwhelming. So I want to kind of condense down my work, okay? So I'm kind of applying the associative law here a couple of times, okay? So hopefully you're convinced that this works. If not, take a moment and think about it, okay? So I'm just grouping those for my own benefit so that I can see more easily what the task is at hand, okay? So I'm going to go ahead and just focus on this first proposition here, this first compound proposition. See if I can get anything out of that not P, okay? So what I'm going to do is I'm going to use the distributive property. And I might present it in a different form than you might see in the text. If so, just try to understand why it's still accurate, it's still correct. So what I'm going to be doing, I'm going to be taking two propositions joined by and I'm going to be distributing a proposition that's joined to that and with an or. So this is going to be P or R and Q or R. Okay, and this would be a logical equivalence you should be familiar with based on those videos that were presented from YouTube. Okay. If you're not convinced, an example I really like is just distribution with multiplication, right? All this is like is, let's see, let's go here. This is just like if I took 2 plus 4 and multiplied it by 5. I can distribute from the right. 2 times 5 plus 4 times 5. Okay? I can distribute from the left too. I'll get the same thing. Okay? And you know, it's really fun to really be convinced of these distributive laws in arithmetic, okay? Because if you believe them in arithmetic, then you can believe them logically, I think. So you know, do some hunting on distribution with arithmetic if you're not really convinced of it, and get yourself wrapped around that before you try to wrap your head around this distribution on logical operators, okay? La la la. Okay, we're getting there, I promise. So we're going to be distributing this negation of P to each of these guys, okay? Now be really careful how these operators come across because it's tricky when you're distributing, okay? The way that I think about it is just taking this or P and applying it to the P, applying it to the not Q, and connecting with an and in the middle, right? So I take the or R, I apply it to the P, I apply it to the Q, and I connect them with an and. That's what I think when I'm doing this distribution. So, oops, I'm a little bit out of my territory here on that left-hand side. So we got, this is logically equivalent. I'm just working on that first compound proposition. Don't worry about the second one right now. One thing at a time. Or, not P. Combined by and, not Q, or not P. Done. Ooh, this guy, I'm going to move this little guy. Can I move this guy? I need a little bit more space, buddy. Okay. Let's go back to drawing here. Or, and we're just leaving that second guy for now. Alrighty. Woohoo! You should see something. You should see something exciting. I hope you see something. Okay. Take a moment. Think if there's something that we know right away. I hope you see it. If not, it's okay. But what I see here is I finally did what I wanted to do. I wanted to put a P by a not P. Woohoo! All right. So if you look in that table, look in that PDF, whatever you've got in front of you, you'll notice that there's a logical equivalence. If I take P, or take a proposition and join it with the negation of that proposition with or, it's always going to be true, because I'll have opposite truth values here. So that's what I'm going to apply here. I'm just going to do a replacement. Instead of that, I'm going to write true. So this is logically equivalent to true and not Q or not P. Oh, believe it or not, we are making progress, okay? It was a long road. This is a long problem, but you can do it. You can do it. And keep in mind, this is like a homework problem, okay? Not an exam problem. Well, your first exam is take home, but I'm talking about like midterm, okay? There's not time to do this, right? But you will have to do proving logical equivalences with these replacements. But it should be something you should be able to do in about 5 steps or so, okay? Not to say it'll be easy, right? But this is a lot of steps, right? Okay. Now, you should see another replacement that we can do right away, okay? Let's think here. If I've got true and a proposition, what happens? What takes over? If I take P and true, I know if I take P or true, I really like that, because then I have true and then I'd be done actually. But I have and, so crap, what do I do? It's okay. I know if I think about and, right? And is only true if both are true. So if I'm combining it with a true proposition, this P takes over. This guy does not matter anymore. Because if P is true, it's going to be true. If P is false, it's going to be false. So P just takes over that. So what we can do, since this guy is joined with an and, I'm going to go ahead, use that logical equivalence that I wrote here. P and true is P. And I'm going to write, not Q or not P. That's all I have left in that first one. That's exciting. Or now we still have a little trouble here over, right? We have some distribution to do, but this distribution is almost exactly like the other one, so we suspect that we're going to get something pretty good over here. And notice what happened here. The negation, that negation piece just kind of went away, right? And that's what's going to happen over on the right-hand side, right? That R is just kind of going to go away. And if that R goes away, I'll only have Q, and then I'll have not Q. So this is looking really good, believe it or not, okay? If you don't see it, it's okay. You will see it. I promise you. We'll get there. So I want to break this down a little bit more. I want to distribute the R to the negation of R so those can be friends. Those guys are friends. That itself and its negation, those guys are magical in these problems, okay? What I'm going to do here, I'm distributing over an and with an or. So I'm going to take that or R with me, or R, whoops, maybe, join with an and, Q or R. Whee! This is a long one, huh, guys? We're doing it. Okay, so I'm going to distribute it. Work on that right one. Work on that right proposition. Negation of Q or negation of P. Or distribute that R. So Q or R and negation of R or R. Distribute that or R. Distribute that or R to Q. Distribute that Q R or R to not R. Join it with an and. Right? That's what's happened. Oh, whoa, whoa. We see something good, hopefully. What do you see? What do you see? Hopefully you see this. Hopefully you see if I've got the negation of something or that thing, I get true. Okay? So I know this is true. All right? True. Let's see what we've got going on now. Not very many steps left, guys. Oh, crap. Hey, work with me here, buddy. Oops. I want the eraser. Delete. Someday I'll get a hang of this technology stuff and be super awesome. Okay. Where were we? Q or R. And true. and true. Same story as what we ran into with the left-hand side. If we take a true proposition, join it with another proposition with and, we're just going to end up with that original proposition. Nothing crazy there. Goodness sakes, you guys, I'm getting tired on this one. I'm going to mess up in videos a lot, okay? I try my best, but I don't know, stuff happens in my mind crazy. And so you just got to let me know, okay? Okay. And the logical equivalence that we use there is if we take P and join it with a true proposition, we just get back to our original proposition there. And that's what we use to replace this guy. Okay? Now, this is looking very, very nice. All I have is just one operator, one connective operator, right? Negation applies to just one atomic proposition, so it's not, calculation-wise, not all that interesting. What I want to look at is say, okay, I've got or, I've got or, I've got or. That is important, right? Not. So if I've got the same operation here, all ors, if I think about associative property and commutative property, really I'm just using the associative property, but I can do this in any order I want. So using this idea of associativity and commutativity, it doesn't matter what order I combine those operators, because I know that the or operator alone, remember, alone, if I've got and in there, don't do this, it will mess you up. Okay. So what I'm going to go ahead and do is just say I've got all the same operation there. I'm just going to remove those parentheses because there's no need to group anything because I can group them any way I want. One more step, guys. Well, no, probably a few, but we'll get there, okay? Now, I really like the looks of this not Q and Q, okay? If I get those by each other and group them, I know that not Q or Q is true. I know true or anything, bunch of things, is true. So literally the light is just shining so bright on us. Okay? Let us go down a bit. Alrighty. So let's do another step. So just like here, like we showed here, the or operator is commutative. So what I'm going to do is just swap the order of not P and Q. So then I'll have that not Q by its friend Q. They love each other. Okay. Now, I can do these in any order I want. They happen to be in the order. That's very nice. Very nice to us. Okay. So I'm going to go ahead and make another replacement. I know that the negation of P or P is always true. So if I take the negation of Q or Q, it's true. So I'm going to replace that with true or negation of P or R. Okay. Now there's a couple of different things you could do. You could think about doing true or not P, show that's true, then say true or R, say that's true. You do two steps here. Or you could use associativity of or P or Q or R is logically equivalent to P or Q or R, okay? And use that to say, okay, this is the same as true, and then I'm going to group that second one to just one proposition. Think about it like one. So if I take true anything, true or anything, right, any compound proposition P, that's going to be true. So we are done, okay? Because I've got true or. The alternative that I was thinking about here would just be to say, okay, I'm going to work left to right because I've got the same operator here. Ah! These guys. Okay. True or not P or R. I say, okay, working left to right, I would start by grouping true or not P. That's going to be true because I'm right. And then if I take true or R, it's true, right? So, but to be really accurate here, I can't quite say true here yet. because yeah, I need to be a little bit more. And so we showed in a lot of steps here that this is a tautology. Okay, and this is probably the most challenging one in the section, but I wanted to show you a tricky one so you're better understood what to expect on the more challenging logical equivalence proofs. Okay, so this is the first proof that you've seen. No, it's not. You saw some truth table proofs, didn't you? So a lot of times at the end of the proof you'll see a little box with filled in, or you'll see a little diamond, or you might see QED. Okay, and maybe you can post on the discussion board about QED. That'd be fun. Cool, guys. All right, I will post this work here. Okay, probably it only makes sense if you watch the video, but hopefully that gives you a second look at it too. Okay. All right, email me if you have questions, and I will talk to you soon.